Hi, questions in analysis. In this textbook, we introduce a theorem that Px be a polynomial of degree n with integer coefficients. If R over S is a rational number with R and S being relatively prime integers, and R over S is a root of Px, then R divides the constant term and S divides the leading coefficient of Px. This is R divides A0 and S divides AN. In particular, if Px is a monic polynomial with integer coefficients and PD not zero for all integers d dividing the constant term of Px, then the polynomial Px has no rational roots. This theorem can be found in many textbooks. Here, we quote this theorem from this textbook. Question 1. Prove this number is an irrational number. Solution. Let x be this number. Then we have this equation. Then we get this equation. If x is a rational number, then x equals m over n with the greatest common divisor of mn equals 1, such that m divides 484 and n divides 1. This gives n equals 1 and x equals m is an integer. This says x is an integer such that x divides 11 square times 2 square. We know the square root 3 square equals 3, and the square root 5 square equals 5. We have these two inequalities. So we have these two inequalities. We see that the square root 3 is not 1, and the square root 5 is not 1. So we get these two inequalities. This gives 4 is less than x, and x is less than or equal to 14. So x is in this set. Since x divides 11 square times 2 square, so the only possible value x is equal to 11. This says this number equals 11. So we have this one. Then we have this one. This says the square root of 5 equals 9 over 2. This gives 5 equals 81 over 4. This contradiction shows x is not rational. Question 2. Are the following numbers rational? Solution. Consider this number x. Then we have this equation. This says we have this equation. This gives this one. This says we have this equation. If x is a rational number, then x equals m over n with integers mn and n greater than 0. The greatest common divisor of mn equals 1, such that m divides 1 and n divides 1. So n equals 1 and m equals plus 1 or minus 1. Consequently, x is an integer such that x equals 1 or x equals minus 1. But we see for x equals 1, this polynomial is not 0. And for x equals -1, this polynomial is also not 0. This shows x is not a rational number. Consider this number x. We see we have those two identities. So we get x equals 4, which is a rational number. Question 3. Find the rational roots of the following polynomials. Solution. Consider this polynomial. Let x0 be a rational root of px. Then x0 equals m over n for some integers mn with the greatest common divisor of mn equals 1 and n greater than 0, such that m divides 2 and n divides 4. So m equals plus minus 1 or plus minus 2, and n equals 1, 2, or 4. So x0 is in this set. We compute the px0 shown on this table. We conclude 1, 1 over 2, minus 2 are the rational roots of this polynomial. Consider this polynomial. Let x0 be a rational root of px. Then x0 equals m over n with integers mn and n greater than 0, such that the greatest common divisor of mn equals 1. Then m divides 1 and n divides 2. This gives n equals 1 or 2 and m equals plus 1 or minus 1. So x0 is in this set. We compute px0. The results are shown on this table. We thus conclude there is not rational root of px. Thanks for watching. Bye.